Continue.
Okay, so a very good afternoon and hello to everyone. I am Dr. Saloni Pandya from Civil Engineering Department, School of Engineering and Technology, Navreshna University. Thank you all for joining us today. It is my pleasure to welcome our distinguished chief guest, Dr. Bhairav Thakkar, Dr. Payal Desai, Coordinator, Civil Engineering Department, expert faculty speakers, and my dear participants to 6 days short-term training program on advances in civil engineering. On the behalf of Civil Engineering Department, I take this opportunity to express my deepest gratitude to Dr. Nilay Yagnik, Provost, Navreshna University, and Dr. Sandeep Vasant, Registrar, Navreshna University, for their continual guidance and motivation for the organization of this short-term training program. Without further ado, I now invite Dr. Payal Desai to deliver the inaugural address.
Thank you, Saloni. Good afternoon, everyone, and warm welcome for today's short-term training program in Advances in Civil Engineering. In today's world, civil engineers are required in every sector of engineering that are essential for persistent human existence. We all are responsible for foundation operation, maintenance, and uninterrupted functionality of the society. To perform this responsibility well, it is important and imperative to keep up with the advance that has happened in the civil engineering field. This program, the objective of this STTP program aims to create awareness on the progress of each and every core branch of civil engineering, such as structures, geotechnical, hydraulics, and transportation area. The program will help every participant to enhance their knowledge, create inclusiveness, and most importantly, will aid in encouraging further research and development on the mentioned area. Thank you again, all the participants, for joining the program, and we look forward for many such fruitful discussions in these 6 days. Thank you, everyone, and welcome again.
Over to you, Saloni ma'am.
Yeah. Thank you, Payal ma'am, for indicating the purpose and importance of this short-term training program. I now invite Ms. Monica Shah to give insight on Civil Engineering Department at Navreshna University.
Very good afternoon to all. I'm Monica Shah. I was thinking to taking a quick tour to the Navreshna University. And the Navreshna University has so many ideas and goals to achieve. Navreshna University was established under the Gujarat Private University Act 2009 with an intent to offer a superior education with the benefits of higher education standards. Navreshna Education Society is the umbrella under which the various educational institutes are going to be initiatives like Navreshna School Summer, Navreshna International School, Navreshna School Vidyani, Nav Nav Kaushalya, Navreshna Sports Academy, and Eklavya models of residential school, including very our own Navreshna University, Vadodara. Basically, Navreshna University is going to be the multidisciplinary university having the 4 different schools: School of Engineering and Technology, School of Liberal Arts and Studies, School of Business and Law, and School of Environmental Design and Architectures. These 4 schools having the 22 programs and about 2,500 students. All the faculties mostly hold a PhD degree, will have a well-equipped laboratories, libraries, and other workshops. The main focus in Navreshna University will be always the education beyond the limit. That is, don't be a minimum one. We'll believe in T-shaped engineers where their roots are going to be very strong and they are going to focus on disciplinary expertise. We'll have interdisciplinary as well as cross-disciplinary work which is going on by the different faculties. If you have knowledge and if you can't serve to your society, that knowledge has no meaning. So we have a strong social connect program called Coach, where the different disciplinary students are work together and they're trying to help the society. Currently, the students are working on Atapi Foundation. Other students are working on their own business and own ideas by the subject called entrepreneurship. They have a more communication skills and they will build their confidence while studying that subjects. Under this, School of Engineering and Technology was started in 2012 with a program of BTech, MTech, and PhD in Mechanical Engineering Department, Civil Engineering Department, Electrical and Electronics Department, Computer Science and Engineering, and IT. In this particular programs, we have more than 1,000 students and more than 40 plus faculties are there. The main resource are going to be the library where the large number of books and online tools are available. The laboratories are well equipped with almost all newly developed instruments. We have a ICT classroom with all the facilities with the continuous 24/7 internet and Wi-Fi available in the campus. For the constant progress of the students, will have ERP systems where our students and the parents can communicate with the faculties and the university continuously. For the other curricular activities, we'll have a different game, sports, and gyms available in the campus. Generally, the BTech program is worked under the motto of "Be what you want to be." That means achieve your dreams, work towards that, and that can be only possible by giving the hands-on training and on each and every programs. So we'll have a different programs in which different subjects where we can work hands-on with the students. Here is the faculty profile of Civil Engineering Department, which is the head by Dr. Payal Desai. And the faculties are Dr. Saloni Pandya, Mr. Nirav Patel, Mr. Rahul Shah, myself, Monica Shah, and Ms. Vaidehi Jain. Definitely, you guys are going to interact with all the faculties during the STTP. Here are the glimpse of surf projects which is done by our students, and that will show how the things are going to be progressed. This is the process of working models, how our students have started working in different dams, other structures, then concrete based projects and other things. This is how our students will start hands-on training for each and every projects, and they will try to learn it more effectively. Here are the some glimpse of industrial visit, because we on the field what is going on, if you don't know how you are going to relate that particular imagination to the real world. So this is the most essential part where students and faculties are work together as a team. The students are not going to be behind in the research also. The many students are going to present their papers in the different valuable conferences, national as well as international. Here are the some fun moments with the students which can make the bond stronger. We'll have a celebrations of different days and the convocation which make the things memorable for a lifetime. We'll have a strong alumni connect where our students are going to give a small talk and they are going to interact with their juniors, and that was going to be become make a whole alumni team which can make the future contact very easily, and they will help their juniors in an effective manner. Here are some major placement companies are given available over here. Geodesigns, Design Enterprise, Greenfields, they are the major ones. The minor, there are so many other industries where our students are get placed. Even more students are going to get admissions in the Canada, USA, and other valuable colleges of India even. So the educations, the hands-on trainings, and the free atmosphere that makes our student confident, imaginative, well-educated, thoughtful, eager to learn, bold, problem solver, soft skill, well-spoken. Best thing is a great human being, and that would be the most important, I guess. Thank you so much. Over to you, Saloni ma'am.
Thank you, Monica ma'am, for familiarizing everyone with Civil Engineering Department at NUV. Now it is my great honor to introduce our chief guest, Dr. Bhairav Thakkar. Dr. Bhairav Thakkar holds a PhD in Structural Engineering from Indian Institute of Science, Bangalore. After PhD, he pursued postdoctoral research at Technical University of Eindhoven, Netherlands. Dr. Bhairav Thakkar was the head of Civil Engineering Department, School of Engineering and Technology, Navreshna University, from 2013 to 2017. He was instrumental in setting the curriculum of undergraduate programs in civil engineering, computer science and engineering, and postgraduate program in structural engineering at Navreshna University. He has supervised various students' projects in the Civil Engineering and Electrical Engineering department at NUV. He has developed a number of commercial softwares for students and professional structural engineers. He has over 40 research publications in international journals and conferences. He has supervised and guided 14 postgraduate dissertations. His research area focuses on finite element method, reinforced concrete, fracture mechanics, continuum damage mechanics, structural dynamics, artificial intelligence, and high performance computing, to mention a few. He moved to Canada in 2017 and is presently working as senior engineer in research and development of Imagine Communications Limited. On behalf of Civil Engineering Department, Navreshna University, I now invite Dr. Bhairav Thakkar to enlighten us.
Thank you so much, Dr. Pandya, for such a nice introduction. I'm overwhelmed. Thank you. And having given this opportunity for me to talk in such a wonderful occasion, I'm really grateful. Thank you once again for that. So the first thing I would like to say is a very big thank you to Mr. Rahul Amin, Ms. Tejal Amin, and the management of Navreshna University that actually allowed creation of such a wonderful thing we call at NUV fondly. And I also thank Dr. Yajanik and Dr. Vasant to actually facilitate such environment ambience in which this kind of STTP and so many other programs which I have been able to witness as well as know of are being taking place. So I'm really grateful and honored to be present over here. So I'm really grateful. Also, I would like to say it was a wonderful introduction by Dr. Payal Desai about the civil engineering challenges that need to be understood before we train our students, before we go into our own research. And I also would like to appreciate the way Ms. Monica Shah introduced the civil engineering department. Before I say anything further, I would like to also say, or rather introduce everyone to certain things which I feel about the Navreshna Civil Engineering Department. Of course, I am very well aware that everyone will be introducing the faculties, but I think I'll take this opportunity to at least, talk about the faculties to the whole audience. So PhD from IIT Bombay and a postdoc from the University of Michigan, Dr. Payal Desai. She is an expert in mathematical modeling and finite element analysis and plates and shells. And I mean, sorry, Payal, I don't think I can actually list down so many things where she excels. So that's the head of the civil engineering department, and I'm really kind of, I really appreciate that. If we look at other faculty, I actually was thinking the tools which we have developed for one kind of a domain should be used, and I would say must be used in other domains. That is very well done by Ms. Monica Shah. She employs the fundamentals of finite element analysis, the finite element method, into industrial wastewater treatment, reducing the COD and the BOD and other such things in the industrial effluents, for which once again she adds one more thing into the kitty, and that is CFD. So she is a person who works on CFD, she is a person who works on FEM, she is a person who works on environmental engineering, and to add to it, she is using artificial intelligence. Wow. So that's something I really call it an interdisciplinary work. And just to add the icing on the cake, She is very ably guided towards her PhD by Dr. Payal Desai. So I really appreciate the work that is being done in that particular area. Of course, that's one direction. On the other hand, if you look at the other front, the land is overpopulated nowadays, and man is moving beyond land to the seas, or rather near the seas as well. Of course, these problems that this kind of a movement faces have been looked at since a couple of decades now, but the research has picked up to a lot. And Mr. Rahul Shah, he is looking at this kind of challenges, which is marine influence of marine environment onto what happens to the structures, what happens to structures under such kind of conditions. I mean, that's something which we do not learn in our undergrads or even postgraduates. So it's a very highly specialized research, and to earn best research awards in that is something just out of the world. So yeah, I mean, that's something awesome. Moving forward, I also remember, we used to give our students, project students, to make some models and basically for their understanding, so that they could learn exactly how things are. And that is where I used to fondly remember the models made by the students of Ms. Vaidehi Jain, who would make road intersections and various other kind of those awesome advanced road structures. The models for them, and she is an expert in road safety analysis. She is an expert in design of road intersections and all that stuff. So that's another great thing which I feel is going on in the department, which should be highlighted. So I'm trying to enumerate these things so that I'm able to appreciate and show my appreciation for all of the faculty of the department. On the other hand, Mr. Nirav Patel, he is working towards not exactly multidisciplinary, but really a multi-problem kind of a situation in which he's using earthquake technologies on self-compacting concretes, and he's kind of done a very good deal of research. A number of his research publications are available for people to view. These things are all above the structure, above the ground, yes, and a lot of things happen. A lot of dynamics on the structure. So we have repetitive loads, dynamic loads. And we are very happy looking at the structure, and everybody who looks at the structure says, yes, it's a very good structure, but he always looks up. But what is over the ground has something much more important beneath the ground, because once constructed, you cannot change that. And that is where exactly Dr. Pandya excels. Dr. Saloni Pandya, who works on dynamic loads on saturated and unsaturated soils and trying to understand what exactly goes on into the soil. Once it is constructed, you can't do anything. So once Dr. Saloni Pandya is done with her job, we can repair our jobs over the ground, but all that is to be done is done in the soil. So here you have a confluence of so many expertises working together, and they are going to talk about their expertise over the whole period of the coming 6 days. So it's going to be a very, very enriching experience, in my opinion. And I'm sure it's going to be really something to take away a lot from. Looking at this kind of a faculty, I had certain things which I wanted to share with you in my mind. One of the things which I actually immediately saw once I finished my master's was when I went into my PhD, was that civil engineering was developed to a point where we can no longer say that I'm working on RCC, no, I'm working in FEM. No, that boundary is no more existent, I would say. We have moved to a kind of point in time where we must pick up one set of knowledge, apply it to the other things. For instance, somebody says that, I'm working on structural dynamics. Yes, he goes about solving mx double dot plus cx dot plus kx plus f is equal to 0. Yes, but then that is just one part of it. 5 decades back, it was enough to say that, yes, I'm working on that particular type of a problem, or I would be working on, say, I'm trying to develop a shell element that has a, say, for example, a rotational or a drilling degree of freedom being taken into account. That would have been great, some maybe 20 or 30 years back. For today's time, kind of, we already do have a huge number of such tools already created, and the research has to move forward. picking up one thing and using to the other. So I could see that, I could experience that for a number of times when we have to use one domain into the other. For instance, I'll give you some quick examples. And why I'm trying to say this is because, as Dr. Payal Desai aptly pointed out, that the purpose of this STTP is to get freshened up with the research updates and what we are doing over here in civil engineering. That's one part. But the main reason is we want to enable everyone to conduct research which matters. And to conduct research which matters means we need to know what are the frontline areas. We need to know where the world is moving. We cannot just get stuck onto an old thoughts. Like, I worked on continuum damage mechanics for my PhD. And I can't say that, yes, I'm just developing those damage models and I'm done. It has to go into a framework of nonlinear finite element. It has to go into mechanics of laminated composite plates or shells, or mechanics of, let's say, the full solids which are orthotropic. I cannot say that I'm just, working on masonry, but I have to consider it as an orthotropic structure. I have to look at what happens to those orthotropic structures under influence of, say, a breathing mode in earthquake design. You have to take number of things. And that is what I was very happy looking at the profile of the School of Engineering and Technology, that everyone, for that matter, practically everybody, all 6 of the faculty are working in kind of, multi-domain, multidisciplinary type of research. And that makes the team so powerful and so strong that I would say that this is the best team that any civil engineering department could hope for. And I'm really very happy to, and proud, I would say, to say that Navreshna University has it, NUV has it. So it's a wonderful thing that such a team is there in the NUV. And it's really great that they are conducting such kind of STTPs, and they are also conducting workshops. So I'm really very happy and hopeful that you all should be able to have a lot of things to take away from this STTP. And while we are talking about interdisciplinary kind of a research, I would also like to share some examples of things which I have been able to encounter in my career, and I have been able to see others doing as well, so that you get a flavor of what kind of areas civil engineers can work in. One of my very own example I'll give you is I've been able to work. I've got an opportunity to work on something we called as Eurodynamic Analysis. I mean, I'm a civil engineer. I'm a PhD in civil engineering with a postdoc in civil, and I got an opportunity to work in Eurodynamic Analysis. Now, what is a Eurodynamic Analysis? Eurodynamic Analysis is analysis of our urinary bladder, and that is done for the healthcare reasons. So what happens is, what happens to the bladder in terms of the surface lining, what happens to the muscles of the bladder, all these things, of course, they go under an umbrella or a heading of biomechanics. But the thing is, it has the same principles of stresses and strains. It has the same principles of orthotropy and elasticity and plasticity and creep and. So it is, and of course viscoelasticity. So it is such an awesome thing to know that what we are learning, let us say in first year engineering, when our teacher teaches us, let's say, the basics of applied mechanics, the basics of strength of materials, we really do not know where all we can apply it. And I got an opportunity to apply those principles to healthcare, and that was a very enriching experience for me. So I was very much interested in sharing that with you, because that was something which I could actually never imagine, that someday, being a civil engineer, I would be working on something on a human organ, trying to understand what happens on the human organ side, and trying to find out, correlate whether certain experimental observation graphs correlate with what we believe in terms of what's going on to the bladder in terms of our simple Hookean stress and strain curve. So these two things, I mean, it's such a wide gap if we look at it from one perspective. They are two different domains. somewhere we are talking of a human organ in medicine terms. On the other hand, we are talking of stresses and strains, the Hooke's law, which we usually give an example with steel. Mild steel, to be more precise. We try to explain our students that, I'm pulling a mild steel rod and this is what happens. And that exactly, of course, in its 2D state, gets used on a very different domain. That is one. However, that cannot be applied if we do not have other set of advances used into structures or civil engineering domain. And that is high performance computing. In fact, high performance computing came into full swing, I would say, maybe around 20 or 30 years back. And slowly it started picking up because obviously, as all of you must be aware, any finite element analysis of a practical structure that we want to conduct requires more than 60,000, 80,000 degrees of freedom to be solved. Maybe I'm kind of, understating 80,000. But I also have an understanding in practical field. While we know that, suppose if I want to analyze the light combat aircraft, LCA, it would be comprising of not less than maybe 4 to 5 million of elements and maybe 6 to 8 million nodes. Possible, pretty much possible. But we do not solve the whole system at the same time. We rarely do. In fact, we do it only in the final stage. And we usually break down all the components, apply boundary conditions, which are kind of as we call as substructuring, and we solve each and every component individually. So the fuselage would be analyzed separate from the wings, and that would be analyzed separate from the landing gear. Now, the point is that I'm trying to drive is that even after all this, I'm not surprised if somebody comes and tells me that I'm working on a problem that's around 80,000 degrees of freedom or 150,000 degrees of freedom. That's pretty normal. And I have, in 2008, I used to work on a software which was for full-fledged finite element analysis of building frames. That would take, I still remember the numbers. It was a Pentium, of course, not compared to today's i7, but on a Pentium, which was having 233 megahertz frequency. It would take almost 2 hours to run or solve a 10 by 10 by 10 building frame. That means 10 bays in X direction, 10 bays in Y direction, and 10 bays in Z direction. So roughly around 11,000 degrees of freedom. 11,000 nodes, not 11,000, 1,000 nodes, 1,100 nodes, and into 6, that many numbers of degrees of freedom. Just for some 6 to 7,000 degrees of freedom, on a banded matrix, it would take around that huge of a time. And then came the time when we could do high performance computing, wherein we could solve the whole structure in parallel. And for that, the major breakthrough was solving equations, or rather performing mathematical calculations on the GPU, where GPU is the graphics processing unit of your computer. Every computer is going to have a graphics processing unit, and the GPU is nothing but having more than hundreds of processors at the same time. It is there in your computer. I mean, I can challenge that whoever is listening to me right now, if you open up your system, you would be having either an onboard GPU, that means you have a GPU mounted right on the motherboard with the processor, or you have a separate graphics card, as we call it, which could be NVIDIA or AMD, and they are the super horses. So commercial software such as STAD, ANSYS, they try to take advantage of those processors, and they have cut down the time of solving those 10 by 10 by 10 is now no more something big that can be solved in less than 1 second. We solve around 80,000 degrees of freedom in maybe just 2 or 3 seconds, or maybe 10 seconds, depending upon the complexity of the whole structure. So that is another research area, which is a very, very hot research area, I would say, for the moment, because over the globe, at least I have been able to read through so many research publications which are trying to say how we can accelerate the solution, because just solving once in a static analysis is not sufficient anymore. We want to do dynamic analysis, and dynamic analysis means we are talking of eigenvalue analysis, means we are talking of actually solving the structure quite a few number of times. And Of course, for a isotropic material, and if we are in the linear range, we are very happy because we just have to multiply the K matrix with a force vector number of times. But the moment I'm entering into a nonlinear domain, my stiffness matrix is no more symmetric. My stiffness matrix changes in every run. I have to solve the system of equations. Now imagine if you have a structure which requires around, say, 20 minutes to solve, and you have to solve it around, say, maybe 5,000 times. What would happen? I'm not going to do that. And that's exactly what people used to do. I'm not going to do that. Then they would find out which are the most important modes. Then they'll try to get only the eigenvectors for those modes and move forward. In today's time, we have been able to move, or rather couple, high performance computing with this finite element, and we are able to move forward. Another very important amalgamation is artificial neural network with structures, the structural design. And that is where a lot of newer software packages are coming up with. For instance, suppose if you just want to do nothing, you just say that, yes, this is the building plan, and you want to solve the structure. You want everything to be taken care of by the software. The software available presently, they are able to do that. They use artificial intelligence. Behind the hood in the engine is an artificial neural network engine, as we know it more as for deep learning. That's what understands that, okay, this is the shape of the structure, this is the height of the structure, these are the dimensions, and roughly then these should be the bending moments, because I know from my previous learnings that, yes, this is how the bending moments and the shear forces are working, and this should be my first short section. The moment I am able to decide that this is my first short section, I am able to converge to a very, very economical section for the building frame in just a couple of iterations, which would require, I remember very clearly, we were about to develop a new building for Navreshna University, what we used to call the laboratory building, which eventually turned out to be the SEDA building, which was for the architecture and education, the new building, as we used to call it. That was a 7-story structure, and it was required to carry a lot of, it was required to carry actually a wind tunnel. It was required to carry our universal testing machine, which eventually we kept somewhere near that earlier parking lot, or the bike parking lot, if it's still a parking lot. And the loads were such, I mean, imagine we are having a universal testing machine to be placed on that particular structure, and it would be obviously subjecting the foundations to such huge dynamic loads that were unimaginable for a building. The dynamic loads which were coming on to our first floor and second floor building primarily, because we were housing the mechanical and the civil engineering on the first and the second floors laboratories, and the third floor was supposed to hold the electrical engineering laboratory, which was talking about high voltage equipments and other heavy, really heavy equipments. While electrical equipments were not so heavy as civil and mechanical, but they were heavy nonetheless. And I was forced to kind of consider loads, live loads actually, to an order of more than 4 kilonewton per meter square, which is rare. For normal buildings, we usually take around 2.5 to 3 kilonewton per meter square, whereas I was forced to take 4, 4.5, and certain known point loads, because I cannot convert a UTM into a live load. So the number of iterations I had to go through for design of beams and columns, which are safe as well as economical, were to an order of nothing less than 70 or 80. You decide a section and you design. The section requires slight change. The moment the section changes, your earthquake loads change because your mass changes. The moment your earthquake load changes, your section changes again. It's such an iteration that you have to keep on doing. In today's time, artificial neural network gets coupled with structural analysis and with structural design and with high performance computing to give you a whole mixture which solves your problem in maybe less than half an hour, or maybe 30, 40 minutes, 50 minutes. So you just start a run, you go and have a cup of coffee, and by the time you are back, the solution is done, and it shows you what exactly it has done in terms of optimizing that entire structure. And with that structure minded, you can be pretty confident that your design is going to be one of the most economical among those who are submitting the designs. So interdisciplinary research has taken a look, a new look, to a point where civil engineering is no more limited to buildings, it's no more limited to bridges, it's no more limited to foundations, but it is something which has to do with going beyond, breaking all the barriers. It has broken all the barriers actually, and it is going beyond to unimaginable domains. For instance, you will be surprised to see that civil engineers work in telecommunications area also, because it's the same set of mathematical manipulations that you learn for your finite element analysis. That's the same things you have to apply into other domains. So just to give you a flavor, if someday you are able to watch a television program which is being telecast by, say, Star, or it's being telecast by Reliance or someone, and you are watching in UHD or 4K, it is very much likely and possible that there is a civil engineer behind that particular program being brought to you. And that is exactly what I was very much pleasantly surprised to see when I moved to Canada. And I really wanted to share these things with you on that. Another thing which I saw, and I think which can be of a very good importance to faculties who are guiding students who aspire to move towards, say North America side, that would be in the northern US or Canada. One of the major challenge which we face, all of us face, when we move from India to Canada or northern United States, is the type of structures are no more RCC. The type of structures are rarely steel. The type of structures are purely wood. And the moment I come and say that, look, I'm an expert in IS 456-2000, I'm an expert in IS 800, and they are like, okay, I'm an expert in steel. Okay, I need wood. That's what they come up with. I need wood, because wood is very different from concrete. Wood is very different from steel, and we just cannot interpolate, or rather extrapolate, our knowledge from concrete and steel into the domain of wood. That's a very different domain. It's a very different expertise, and that's an area which is kind of, I would say, a very dark area. The wood designs, of course, a lot of research has gone into it, but I've seen so thin number of papers that couple finite element analysis with wood, with other analysis such as CFD or something on that line. For instance, if I have a wood structure, which is, let's say, supporting a bridge, I have a wooden pier for a bridge, which is pretty much possible. Then there is water flowing by that particular wooden pier. I need to analyze it using CFD to get the loads. I need to analyze it using finite element to understand what's going on in that wooden pier. And I need to know the material, which is nothing but an orthotropic wood that is going to take that load. So it requires, again, amalgamation of all these three things, a confluence. And there is a very bright scope in that particular domain. Very few publications have come up so far which can kind of, establish the area. So if we are going to do something on that area, you should be among the frontline workers in that particular area. So these are certain areas which I thought should be awesome in order to work on. And last but not the least, kind of an area which strikes me at this very time is what people are trying to do is this. They are trying to move working from wind tunnels into computers. So basically, say for example, I remember very clearly one of the talks which was given by Meru Pathak in one of his presentations earlier in NUV. The whole idea is like this, that if you are constructing a new building, then what happens to the old building? I mean, I constructed one building, say for example, let's say Kirti Tower. Kirti Tower is something very popular in Baroda, and that's the reason I'm using that as an example. Let's say I constructed Kirti Tower. While constructing Kirti Tower, I consider certain number of forces based on my IS 875. I try to work out what are the loads. I try to say, okay, this is a good design, and I give that design, and I'm very happy about it. Now, what would happen? Just imagine if two twin towers come up right besides Kirti Tower of the same height. After say 30 years or maybe 40 years of construction of the Kirti Tower, even if I know that it is 40 years, I do not want Kirti Towers to get damaged, right? Now, what would happen if those two other towers come up? You can imagine that those two towers right beside Kirti Tower are going to create what we call as a venturi effect. And the wind blowing between those two new towers is going to accelerate and hit the Kirti Tower at a much higher velocity, causing much higher pressure, leading to much higher loads than what the engineer who would have designed it 30 years back or 40 years back. I don't know how old the Kirti Tower is, but at least I remember having seen it since my early college days, which was 1995 and odd. So Kirti Tower has been there since 40, 50 years. I don't know when exactly it was constructed, but for sure, 40 years back, the engineer would not have, or the designer would not have considered the new loads which are getting imposed on the building. And what would happen if those new loads are more than what the building can take? The building is simply going to collapse. It's going to simply crash. And who's responsible? I don't know. I don't know if we can actually blame that engineer for the design. We can't. Can we blame the new engineers? No, they followed the IS laws. They follow the clauses which are laid down by the Indian standards. So nobody is to blame. And who is to lose? All the people who lose their life and the property, they are losing. So that's not something which we can allow. The municipalities and the corporations are now slowly moving towards understanding or recognizing what would happen to an old structure if a new one is getting constructed, but we don't have enough tools. And that tool can be wind tunnel analysis. You know, you construct your structures in a wind tunnel on the scale models, of course, blow the wind across them and try to see what happens to those structures. Those things are huge in cost. 5 years back, when I was in India, and I used to find those things out, and I was working very actively on that domain. Well, I still am working actively on that domain. There was only one company in India who would provide you with such kind of wind tunnel analysis for buildings, and that was, if I'm not wrong, it was Shayan Talati, and that was in Bombay, in their Bombay office. Bombay office would take those projects, but they would send those models to somewhere in their US facility where they had a wind tunnel, and they would run those experiments, and they would run those wind blows over buildings, and then they would be able to tell you what the loads are. So imagine people want to do it because you want to construct 70-story buildings in Gujarat now. That's something which everybody wants to do. And another 10 years and we'll see so many 70, 80, 70 structures, 60 structures building coming up. But they need huge number of wind tunnel analysis. And we don't have anything out there, nothing. Okay, so what people want to do is let's have it done in a simulation. So yes, while Fluent is there, we could do it in ANSYS Fluent, CFX, we could do that. But for that, you have to make a model, finite element models, which would be kind of, on fluid structure interaction, and blow the fluid over it and get the whole thing out. So basically, we are moving towards a direction which is very, very much interdisciplinary. I would say not only interdisciplinary, it is inter-engineering sciences. In fact, not even inter-engineering sciences. We are applying it to biosciences now. So we are going into such a domain where the whole world is open to us. The world is our arena, and we have so many things which we could do. I would just say we are moving into a kind of era. We are moving into an expansion kind of an era where the number of research problems are multiplying exponentially, and we can just select what we want to pick up and do it. And I'm really very happy and excited actually to see that NUV SET is just ready to do that. And I'm really very, very much eager to know, and I'm excited to know how our other colleges and universities are doing. That would be an awesome thing to know. But one thing is for sure, I really hope that in some time we should become a workhorse. We should become a superpower for this kind of interdisciplinary research. So that is exactly what I wanted to share with you. These are some new directions. Well, I hope they are new. I don't know if at all you already knew about them. Nonetheless, these are the things which I was thinking that these are the research directions, and I should be able to talk about what I have seen so far. So I hope you people have a very, very fruitful 6-day STTP and learn a lot about the advances that are going on in the civil engineering domain. And I'm sure you will have a lot to take away from this STTP. Those who have been able to register for the STTP, I would suggest it was a very great thing that you did, a smart move, and I'm sure you will be really rewarded by the STTP. So I wish all the best to all the participants, all the faculty who are going to present. And again, I can't understate, I can't overstate, sorry, the heartfelt gratitude and honor which I am feeling to have been invited onto this STTP. So thank you so much, all of you. And I hope you have a great time, and I wish you all the best. Thank you.
Thank you, Bhairav sir, for such an insightful and informative talk on the use of civil engineering principles in multidisciplinary fields and various new research areas in the field. Thank you so much. Now we move forward to first day session on durability of concrete structures, a concern for all. Session will be delivered by our expert faculty speaker, Mr. Rahul Shah. Mr. Rahul Shah holds BTech in Civil Engineering from MS University, Baroda, and Masters in CASAD Structural Engineering from Nirma University, Ahmedabad. He joined Navreshna University in 2015. Before joining Navreshna University, he worked at Nirma University as an assistant professor. He has total teaching experience of over 10 years. Mr. Rahul Shah has guided several postgraduate and undergraduate projects in the area of structural analysis, design, and concrete technology. He has published many research papers in peer-reviewed international journals and proceedings of international conferences. He is a recipient of Students' Choice Best Instructor Award at NUV and Best Research Paper Award at prestigious international conference held at NIT, Silchar, Assam. Currently, he is pursuing PhD in area of concrete technology, structural engineering. I now invite Mr. Rahul Shah to deliver the session.
Thank you, ma'am. Yeah. A very good afternoon to all of you. My name is Rahul Shah. I am faculty in Civil Engineering Department at NUV. So my today's talk will be on concrete durability, which is I feel that it is concern for all civil engineers. So let us see that the topic is very simple, but I hope it will be interesting too. So this is very famous quote that if you don't have diet, you can't cheat on it. So if we want to describe the durability, which is in general, you can say that on layman's language, what is durable material which lasts long, right? But if your material quality itself bad, you can't comment on the durability. So first of all, think that you must ensure that you should have great material, and then you can talk about the durability aspect. So concrete in general inherently is a durable material. Either it can be RCC or PSC. They serve as a durable material if it is good in all the aspects, right? But over the time, over the years, around the world, there are numerous examples where there are, in some cases, there is premature deterioration. Now, what do you mean by premature? Generally, when we are designing the things at design office, we generally consider some design period that this structure will last for, let us say, 50 years, 70 years, 40 years, 100 years. So before that, if it fails, we can say that it is premature failure, right? So someone may ask that, then what is the problem for that, right? But the issue is that if we go for the repairs, sometimes it may involve more cost than its construction cost, right? So it is a serious concern because country's infrastructure economy is on the infrastructure only. In this particular uh, scenario, it is very important to understand why it happens, what to do to stop that, and is there any particular way to stop it, right? So uh, in India also, it is been observed in general in coastal regions and the industrial belts. So basically, it is a area which is not very well documented, although over the period of time this premature deterioration is largely reported in uh, developed countries. In our India also, it is there, but it is not so far reported much. So if you talk about stages of life, right? So for human, from a small kid to a grown-up man, so this is called as the early age of the life, right? And uh, as we all know that early age is full of joy, happiness. But when we get the adulthood, then there are so many issues around us that will lead to stresses into our life. It may happen to concrete as well. In early life, let us say 5 years, 10 years, concrete behaves exceptionally well as per expectation. But once it reaches to some, let us say 20 years, 25 years, then these fingers are pointed out on that. And what are these fingers? Let us see that. But before that, we should know that what is durability in a way, or we can say that what is the book kind of definition of the durability. So if we talk about meaning of durability, if the concrete is able to resist against all this action, like weathering, maybe some chemical, may abrasion or any other process which deteriorates the concrete in any way, is called as, if it is able to resist, then it is called as a durable one. If you talk about Indian context, as per IS 456, the concrete should satisfy the exposure condition. Then we can say that the material is, or concrete itself is a durable material. So if you talk about factors which affects the durability, so generally there are two factors. Uh, First may be the concrete system, and second may be the environmental factors, right? We will see these all factors in detail, but in general, concrete system include materials, the ingredients of the concrete, the process in which we will make the concrete, that is nothing but the processing type of the thing. And if you talk about service environment or simple environment, then there are some physical effects as well as the chemical effects are also present. So when we say that the material is durable or concrete should be durable, now there are several causes of concern, and there are some causes which accelerated deterioration. And the deterioration means corrosion of the steel, frost action, chemical effects, and ASR. Now, in generally in Indian context, frost action is not that much evident in uh, most of the part of the country, but all other these three effects are evident. Because when we talk about concrete, we know that concrete is not at all generally placed in isolation. It is always with the reinforcement. So when reinforcement fails, we can say that RCC has failed. In a way, material has failed. That is nothing but concrete has failed, right? So these are four factors which causes the deterioration. That question may arise that why some very old structures are still durable, right? When we talk about some, let us say this is one example, that Coronation Bridge in Siliguri. It is built in 1940. Still, it is in the service condition. Still, it is in nice state, even though there may be some deteriorating agents around it, right? So this is a very old structure, but still it is durable. There are some answers, we'll see to it later on. Gateway of India, built in 1930, still it is very much durable, just on the face of the sea. Mumbai Central, again 1930, still it is durable, right? But if you compare this structure to newer one, right? Then, or it is not very great. So if we see the old structure, this is our ultimate expression, right? We are just like Munna Bhai, and we say to the concrete, you have done exceptionally great work, right? But if you compare this old structure to new one, then this may be a 10, 15, 20 years old structure in marine environment. So it is not having a great response against the deterioration conditions. So if we compare our old structure and new one, old concrete, it still holds very strong compared to the new one, right? So this is very true for concrete also, that is older generation versus younger generations, right? So there are some issues that we need to investigate, right? So there is some gadbad. Let us see why it has happened, that why ordinary or why newer concrete is not surviving as of the older one. Now if you can recall your basic concrete technology, Abraham's law, when you decrease your water cement ratio, your strength will also increase, right? And if you have focused on commercial TV or elsewhere in other media, I will not name the company, but it all the companies focuses on only one property of this concrete, that is nothing but the compressive strength, right? Everyone says that my cement is best, my concrete is best because it has got higher compressive strength, right? So there is over obsession type of thing in the concrete itself, right? Because all other parameters are sidelined, right? And how to achieve greater compressive strength? We know that if we reduce water cement ratio, our strength will be high, right? Now there is one issue. If you reduce water cement ratio, then there are issues with the durability aspect, workability aspect. And if you can work with that, if you can manage the workability with lesser water cement ratio, it will observe higher strength, right? So slowly and gradually over the period of time, let us say last 20 years, 30 years, 40 years, these factors has changed the characteristics of the cement. Like if you can compare the uh, chemical analysis of the cement, the C3S content was increased by 20 to 25 percentage, C2S was reduced by 15 percentage to achieve the properties. Which properties? To achieve greater compressive strength with lesser water cement ratio, right? So if we work with lesser cement ratio along with some admixtures, we may get good workability, and that will lead to by lowering the water cement ratio we can get the higher strength, right? So our this obsession is taken care of, but this particular practice has led to some problem. It has uh, uh, the process of initial setting time, the early strength hydration, formation of secondary products in cement phase is also not handled properly. So if we in nutshell, suppose we want to say that which are the factors which affects the durability, right? So first and foremost is porosity and permeability, right? Because when concrete is more porous and more permeable, there are chances that concrete will attract more water to it. There may be the chances of corrosion into the concrete. So if concrete is more porous, even though you have used the excellent material, it is all goes into the vein. Second thing, the mix characteristics. So if your so all these things are very much basic, no rocket science is involved, but these are very much important aspect that often neglected. So mixed characteristics are also one of the major concern when we work for the durability aspect. Then type of the cement and aggregate, because to achieve the higher strength, sometimes the chemical actions are also affected. Then if it is more porous and more permeable, obviously there would be presence of cracks. There may be the shrinkage cracks, maybe due to the higher heat of hydration. These cracks may also be present. So these are all small things that eventually form the durability into the structure. Then thickness and quality of the cover is also very much important, because if you this thing is also proven in the laboratory. When you increase your cover, and uh, then your resistance against the corrosion is also increased. So these are some characteristics which affect the durability. Now let us see that what is the current scenario in concrete durability in a globe or in India. So as I told earlier, very lesser documents are there for the for research, or this deterioration is not widely documented. So all these documents are available in developed countries like Europe, Canada, and US, as well as some parts in the UK. So National Material Advisory Board in 1987 published a report. They have reported around 2,53,000 concrete decks which was deteriorated, which were only 20 years old. So it is this 20-year-old concrete is not a older concrete. It is a quite young type of concrete, we can say, because we assume 100 years as a design life. FIB bulletin also reported various premature deterioration in Canada and Europe. It expressed concern about the in-surface performance, lack of durability, type of deterioration, and probable reason behind it. National Durability Grade Report in UK in early 80s. You can see when we have not started RMC in our country, in that particular time also they have documented all these uh, uh, deficiencies into the concrete. So they linked durability and impermeability, which ultimately proved the primary concern over the understanding the failures in the durability aspect. So one major shortcoming was expressed that exposure conditions were arbitrary. Environment was measured, or we can say that they have documented that proper exposure conditions were not well defined, which is there in the case in our particular IS 456, where we only deal with medium, moderate, severe, very severe. No one tells that what do you mean by severe, what do you mean by extreme. It purely on the basis of designer, right? Although there are some guidelines that in the coastal area you have to take this type of uh, exposure condition, but in general it is not very much documented. Similarly, for the European standard in 2000, severity of the exposure was also considered, and deterioration mechanism like carbonation, chloride ingress, chemical attack were also documented. Indian scenario is not very good, although we have just started to shift to RMC extensively nowadays. But there are some loopholes, or there are some setbacks that hinders the growth of the proper utilization of the RMC. Infrastructure industry, positive sign is that the infrastructure industry is around 10% of the GDP in the 12th 50-year plan. And ICJ also published performance based specification in 2005. So that is a good sign that slowly and gradually, not directly, we are moving towards the durability aspect. So there are certain crucial issues that every engineer is facing, not in India, but most of the developing countries. That first of all, addressing deterioration mechanism. So unless and until we don't know from what particular reason the concrete is deteriorating, we cannot help our concrete to sustain, right? So suppose we are sick and we don't know what is the reason behind that, then we can't help. It is similar to this. Second, lesser use of RMC. So if we do not use RMC, so hand mixing is not a big problem. But if there are some quality issues, then it will make trouble, right? So as far as possible, the focus should be to use RMC in almost all sites. Need of integrated code. So right now I will share one slide in which we'll see that we do not have any code. I'm talking about India. Any code which explain the durability factors and guidelines, although there are some parts of durability aspects in variety of the codes. uh, Durability centric test and specifications are not present. So basically it is a big issue or crucial issue or aspect in the this durability as a whole. We do not have performance specifications. uh, we do not use high strength concrete. We are still in the mindset of M2025, and we are not having we are not knowing importance of high performance concrete because we are always fascinated with the strength figure. So there are certain challenges. First and foremost is clear understanding of the deterioration mechanism, as I have stated earlier. Then current codal provisions, exposure condition are not at all enough, because someone is living on, let us say, Saurashtra region, and someone is living in Bombay. Both have got the similar conditions in a marine aspect, but how these two fellow consider the exposure condition, that totally changes the design. Then methods and parameters need to be addressed. What may be the test method, that I will explain later on. Then durability parameters, what may be the limiting value, how use of supplementary cementitious material can be used, that is also one of the bigger challenge. And if we want to correlate this measured parameter, and we can correlate with the service life model, how to include into that what may be the crucial parameters or input parameters or affecting parameters, so that has to be taken care of. So uh, when we talk about major deterioration phenomena and transport mechanism, so first of all we should know who are the culprits, right? So who are the responsible, who are responsible one for this? So first of all we need to see that. So major deterioration is by this six deterioration phenomena. They are generally called as 6Ds. First one is sulfate attack, second one is seawater effect, third one may be acid attack, next one may be alkali silicate reaction, freezing and thawing, and corrosion, of course. So if we talk about sulfate, generally when soil or water containing sulfate affects the concrete, then it is called as the sulfate attack, right? So basically it will include extensive cracking, expansion, loss of bond between cement and paste aggregates, right? So these are three commonly observed effect due to the sulfate. Although we will not go to into the chemistry of the part, but we should understand that when concrete or RCC is affected with the sulfate, then these three effects are very evident. So uh, I don't think that this chemistry is very much required at this particular time. Uh, uh, so this particular uh, attack, sulfate attack, is generally by solution of sodium or potassium sulfate, right? Sometimes magnesium sulfates are also there. So depending upon sometimes this all type of sulfates affects the concrete very badly, right? So it will damage the cement matrix. Typically it will expand, it will crack, and generally spalling of the concrete may affect. So generally loss of strength is evident from the sulfate attack, and atteringite is a common source of issue in the this particular reaction. So how to protect this, right? So there are so many theories, and right now commercial cements are also available. that super sulfated cement, right? But apart from uh, because this super sulfated cement can't be used in in marine region because there are uh, higher chances of corrosion, right? So that is also one of the thing that we need to take care. So other parameters are use of low C3A cement, lower water cement ratio, use of high alumina content. So these are the ways in which we can protect the uh, concrete, right? So apart from sulfate, seawater is a evident one. We know that most more than 50 percentage of the sea in the our country's boundaries are affected with the or attached with the seawater, right? So it is very important that uh, uh, we need to understand this phenomena of seawater. Generally, seawater has different type of salts. It may be a sulfate as well as the chlorides, right? Sulfate, as we have seen, it will reduce the it will soften the concrete, right? And chloride may uh, increase the potential to uh, corrosion to the reinforcement into the uh, reinforcement bars. So apart from chemical deterioration, there are some physical, like crystallization. Crystallization is nothing but when we know that the waterfront structure along the sea line, so there is a constant waves coming to the that waterfront structure, and cyclic wetting and drying cycle are observed, and that may lead to crystals. And there are some microfine spores, and that will lead to salt crystal, and that will pressurize the pores, and ultimately it will increase the gaps and increase the width of the cracks, right? Acid also one of the major phenomena when we talk about sewer lines, when it is made up of concrete, and there is a sulfuric acid in the sewer. It will create the acidic environment into the concrete, which ultimately reacts with the uh, CH, and that will lose that concrete will lose the integrity in the, it will soften the material. Alkali silicate reactions are also one of the major parameter, or when we are very much sure about all our external agents, but sometimes by mistake we consider this reactive material as a aggregate, then entire thing will fall apart, right? So there is a line diagram that you can see. So siliceous igneous rocks may lead to alkaline when it is exposed to alkaline aggregates. Then explosive gel will form, and ultimately it will pressurize the pores and concrete may fail. Next one may be the corrosion. Now we know that corrosion is of two types. First may be chloride induced, and second one may be carbonation induced. So these are two major phenomena. So generally, it depends on availability of the oxygen, resistivity of the medium, and passivation of the steel. Now, when we talk about concrete ingredients, right? Concrete ingredients is nothing but let us say concrete has a complete family of various ingredients. When you compare with let us say this family, right? So there are so many ingredients in that, right? Some may be major one, some may be side roles, some may be notorious one, some may be reactive, right? Similar to this, our concrete has also this family of ingredients. Major and most famous is cement. Cement cannot react without water, then aggregates. Then some special characters are the in forms of special chemical admixtures. Some supplementary cementitious materials are also being used. So how this affects the durability, that we'll see. When we talk about cement, there are numerous type of cements available, and generally the quality control in this type of cement is very good. So this care is been taken in the cement plant, so that all the chemical contents in this particular cements are taken care of. Supplementary cementitious material includes fly ash, GGBFS, silica fume, metacholine, and ultrafine slag. Again, they refer to some Indian standard. uh, Fly ash is the most common and most popular thing. I think all of us are knowing the importance of fly ash. I'm not going much into the detail, but it is being used since last 60 years. IS 3182 gives us the physical characteristics about the fly ash to be used, and it is reportedly decreases the permeability by the 30%. So if permeability reduces, automatically the durability increases. GGBFS is also one of the most famous supplementary cementitious material after fly ash. It has got both pozzolanic as well as the cementitious properties. It has got good hydration reactions, as well as it is also effective in counteracting against acid attack and ASR. So one thing is very much evident, that for lower grade concrete, when we are using grade 25 or let us say 20, right? When we use GGBFS more than 30 percentage replacement, it may be supportable to carbonation. So when there are chances of carbonation and your strength is lesser, it is not advisable to use this slag, right? So this is most important thing that we should take away with us. For lower grade concrete, GGBFS more than 30% is not at all recommended, considering the durability aspect, although it may increase the strength. Similarly, silica fume, so it has got ultra fine powder with 85% silica content. So generally dosage are used in the terms of 15 to maybe 20% sometimes. And if you can mix with GGBFS and fly ash, it shows better resistance against the sulfate attack. I am also working in a similar area of research where I am using GGBFS, fly ash, as well as silica fume to see the effects of these SCMs in marine concrete. I'm also checking the resistivity of the steel, which is embedded into this type of concrete when it is exposed to the seawater. Metacholine is not that much famous, but also can be used as a supplementary cementitious material. Uh, Now, if you talk about current practice, uh, IS 456 has some durability requirements. What durability requirements are that we'll see. Uh, IS provides the limiting value in terms of minimum grade of concrete, maximum water cement ratio, minimum cement content, and reinforcement cover requirements. That is all about normal durability requirement. Okay. So in a way, it is a fair practice or fair idea that if we can limit all these things, automatically it is advisable to increase the durability, overall durability of our structure, right? So generally, just by looking to the first aspect of all these things, one may say that, let us say we limit our minimum grade to, let us say, M15 or M20. If we increase the grade, it is more strong and against the all bad actions of by any means that we have seen 6Ds. It will be good against that. That is the first impression that we are having. If we can limit our water cement ratio, again again we can say that we can limit our minimum strength. If we can use minimum cement content, then we can limit our durability, minimum durability, and cover requirements. Ultimately, if we take care about all these three, right? If you can see closely, it is, although it is improving the durability a bit, but it only improving the compressive strength of the cement, concrete, not actually helping out in improving the durability, right? See, our what is normal practice that we follow, that we always uh, follow what is being followed from years, right? So there are still tendency to use M20 concrete in rural area or not very much important projects, right? So actually coastal belt requires M30, that as per the durability criteria of IS 456, but it is not being followed, right? So again, SCMs are not much being used as it is should be, right? So, and our natural tendency is that if we use more cement, it will improve the durability, but it is not, right? So it actually hampers the durability. How it is hampering? Because if you use more cement, then there will be more heat of hydration, and that ultimately increases chances of shrinkage cracks, right? So whatever current practices, that is alarming. If you talk about leading research and development across the globe, then these three, I guess, will sufficient to understand uh, the real concern of what we are lacking at. So first, research was investigated the role of cement content in the durability. They have kept fixed cement ratio and lowered the cement content up to 22 percentage, which has no adverse effect on the concrete, right? So that our traditional thought process of using more cement has vanished. Increase in the cement content, I'm reading out this, increase in the cement content lead to reduced sulfate resistance, increase the chloride diffusion, right? So that is the reason we cannot use this to the super sulfated cement into the marine zone. It increase the chloride diffusion, right? Second paper or second study was on the behavior of concrete with different water cement ratio in the range of 0.45 to 0.70. They have observed the capillary absorption and chloride ingress reduced with reduction in cement content for water cement ratio using water reducing admixtures. Uh, just a second. Second paper. Uh, uh, Third paper was on broader range of cement content. If we increase the cement content by controlling water cement ratio, does not increase the strength, right? And increase in the cement content increase the chloride diffusion and shrinkage. Now there is one very important note, that ACI code does not specify the minimum cement content. It only suggests the minimum grade of concrete and maximum water binding ratio. So Indian code uh, suggests the minimum grade of concrete, minimum cement content, and that may lead to the durability problems. Okay. Now, when we talk about durability assessment and design, right? There are too many standards, and they are all confusing. Let us see. So these are some major standards referred for construction in concrete. They are IS 456, IS 4392, sorry 4326, IRS code, some IRC code, MORTNH, and British standard for high performance concrete. So if you see the major highlights of each code, uh, 456 gives general exposure conditions, then limiting values for minimum grade, maximum water cement ratio, and minimum water content, or sorry, minimum cement content. It limits, so some values or limits of chloride and sulfate in the concrete is also mentioned. Some minimum cover for the various exposure conditions are stipulated. Specific durability issues are addressed. Inspection and testing for slump and compressive strength are measured, or some guidelines are given, and they have in general said that we have to use NDT. So it may be very raw in terms of uh, specifications. Similarly, for 4326, it generally follow the specifications, but has got some additional criterias for limiting values of workability, quality control, and calibration of the equipment, etc. IRS 1997, it actually highlight the coating on structural element for extreme environment. It also talks on water permeability. Uh, IRC 112, which is the latest one. Mild exposure condition is removed from our IS 456. One uses that IS 456 is going to be in a new edition in, let us say, I guess in 2022. So let us hope that they include all these provisions. Now anticipated service life for 100 years. MORTHN code is suggesting the water permeability, which maximum permissible depth of 25 mm. And similarly, HPC concrete for railway ministry, they have limited the use of cement product, uh, that is 380 kg and not more than 450 kg per cubic meter. So they have given a bound range for the cementitious material. It may be a good thing or bad thing, we don't know, but these are some major highlights. So there are some international projects that has considered some durability parameters are listed down. So let us see them. So if you talk about test method for accessing durability, uh, these are some, I will not go much into the detail part, but you should know that these are some tests which are being proposed based on researchers idea and belief across the globe. So they may be gas permeability, water, chloride, resistivity of the concrete, corrosion initiation, sulfate, ASR, abrasion and corrosion of erosion of concrete. So these are some list of tests which may be proposed for these listed parameters. Apart from this particular table, we can say that these are very much common tests: diffusion cell test, water sorptivity test, bulk diffusion test, salt ponding, RCPT. Then half cell test are widely used when we talk about NDT on the concrete, when we talk about the marine type of concrete. Let us these are some few test setup for this listed uh, test. Just I'm showing the photographs just to have an idea about that. So major test method for sulfate is expansion test. For freezing and thawing, it is mass loss test, dynamic modulus test, UPV assessment, ASR. So expansion is a very crucial one, and abrasion, mass loss and depth of wear is to be considered. BS 8500 is industry leader in terms of durability aspects, where you can see that they have classified each and every aspect of the exposure class. So such detailed description is required. So they have classified in various classes, that is no risks for corrosion, they have detailed as X0. So this is one of the example, although there is a huge list of classification for sulfate and all that things, but I am just showing just for your information. Similarly, corrosion induced by the carbonation, so they have classified as XC class. Again, they have subclassified in state where dry or permanently wet, wet rarely dry, and moderate, and humidity uh, conditions where structure is exposed to this type of conditions, right? So they have subdivided these classes. Then if it is influenced by the chlorides but not from the seawater, right? So they have again said that if not from the seawater, then from what? From the chlorides, these icing salts, and from the sources other than the seawater. It may be from the soil itself. So moderate humidity, wet, rarely dry, cyclic, wet, dry. So you can see that in all classes, if you can see this cyclic over here, cyclic, and this is the case in which corrosion is induced by the chlorides from the seawater. Again, cyclic will give the maximum importance. So these three classes are of real concern, because when cyclic wetting and drying is happening, then it is more crucial to so combined effect of physical as well as the chemical deterioration will take place, because in physical the salt crystallization will occur, and for chemical, the normal process of carbonation and uh, corrosion is taking place. Then freeze and thaw axis classes, from starting from 1, 2, 3, and 4. Again, they have classified with some of the classes, again with explanation, right? So these are some example. So our ultimate goal is to achieve the durability, right? So we can say with full confidence, like we can write on the bond paper that our structure will last for, let us say, 50 years, 20 years, 40 years, 200 years. But to how to reach to that particular point, then this is the our goal. And let us say we are starting over here, right? How to reach from this point to this point? So there are maybe 5 steps or 5 points that we have to take care of. So first one is planning. We'll see them into the detailed planning of exposure environment, then material selection, then construction process, on-site testing, and acceptance criteria for the durability. So these are 5 major points or checkpoints that will ultimately reach us to the required level of durability. We are not saying that the ultimate level of durability, it is required level of durability that designer wants, so that the premature deterioration or failure does not happen. If we talk about first one, so I am discussing right now this first point. So planning of exposure environment. So appropriate environmental classification has to be done. Then micro environment difference in large structure. Suppose there is a jetty. Jetty is a long structure, right? Then or there may be some uh, bridge. Some piers are under the water, some may be under uh, supported on soil. Then there may be chances that some pier may experience the severe environmental effect, and some peer may receive different environmental effect, right? So that micro environment difference to be taken care of. If we talk about material selection, then we have to be very much sure on binding type, right? Proper amount of C3S, C2S, or whatever chemistry is involved into the cement, that has to be taken care of. Alteration of the mix design according to aggregate types. Sometimes uh, depending upon the surface texture, water absorption, and all other parameters, there is some minute adjustment in mix design need to be taken care of. If we are using some mineral admixtures, then according to the local site conditions, we have to take it very wisely. Otherwise it may backfire to us, because uh, what are the uh, what are the reacting agents into that particular environment has to be taken care of. And to achieve required workability, we have to use superplasticizers. uh, During the construction process, these are very common advices that everyone has to follow. That regarding storage of material, batching, mixing, moisture measurement, that if moisture is observed uh, different from the mix design, then certain corrections are to be made. Then addition of chemical admixtures, compaction strategy and all. This is fine. Then site testing. Then what should be the scope and frequency of the test? Laboratory specimen test. Then test on concrete in structure. This is very much important. Once structure is constructed, frequent checkup, just like human body, yearly checkup or 6-month checkup twice in a year is required, similar to human body. So, and acceptance criteria. So what is global perspective into that? what what are the precision levels in the laboratory? If you talk about corrosion, what are these limit for RCPT, and water penetration has to be set, and what field experience says, and all should be taken care or wrapped in acceptance criteria. Now these are some interesting durability centric provisions which have been used around the globe. This is first from Oresund link, which connects the Copenhagen with South Sweden. It has got tunnel, raging part and bridge part. They have estimated 100 years of service life, and they have to achieve this required level of durability. They have used low alkali cement, supplementary cementitious material, and more cover. See, there is no magic in this, right? It is all common thing, but they have not only focused on the strength. You can see that binder is only 340, right? So this is very nominal. Still they are targeting at 100 years in this difficult exposure conditions with the help of these three contents. Next is this bridge, Confederation Bridge, which it is in the Canada, in Prince Edward Island. It has got 44 spans of 250 meter each. It has got severe marine exposure conditions. High performance concrete of 55 MPa is used. They have used low alkali blended with silica fume. Air entertainment is 5%, and they have estimated as 100 years service life. New Panama Canal. They have expansion of Panama Canal with 5 million tons of concrete. They have expected service life of 100 years, and maximum 100 coulombs in RCPT value is set, right? And they have minimum concrete cover as 75. And initially, this is very much important, that in estimated crack initiation project period is 100 years. So this is nothing but the service life equation they have used in that, so that they have taken care of all the parameters which can initiate. So this particular parameter is, or initial service life, or first crack is generally as per Tutti's model, which is very much famous in service life prediction, that tell us that what is the initiation period and how after that the concrete will behave. Riyadh Metro, it is again designed for 100 years. So this durability is for 100 years. It is not like structural life is for 100 years. And the carbonation depth after 100 years is 35 mm. So you can see that their confidence that after 100 years also, this depth is not more than 1.5 inch. It is combination of OPC and microsilica. Uh, this all tests were taken care of: RCPT, water absorption and permeability, and some international standard have been taken care of, and maximum water cement ratio is 0.45. So this is not a new, right? Uh, this is also not a new, but this is a new thing that they have taken all these criteria. Chennai Metro, it is a prestigious project for our country. So design life is, it is a design life, right? Design life is 120 years. Minimum cement content was 350 as per Indian standard. Maximum water cement ratio was 0.45. Concrete grade is M35 to M60, and provisions are made to reduce earlier shrinkage criteria. And they have targeted this durability of fire resistance for 4 hours. Statue of Unity. So generally, it is situated in the on the bank of Narmada. So generally, no deterioration factors or parameters are affecting, because it is quite away from the nearby sea. And so, and this center core of this Statue of Unity is also covered by this metal sheet. So it is not it is protected from the weathering action. So they have used, though they have used blend of fly ash and GGBFS, and concrete grade in the core is M50 and M60. This is a proposed project, Chhatrapati Shivaji Maharaj Memorial. It is 210-meter tall. It is surrounded by sea. So they have some durability issue by the chloride, and they generally have provided the cover guidelines, as well as some as far as I know, they have followed some European standards. Now, if you want to uh, move ahead with quality assurance, right, then how we can, as a structural engineer or quality control engineer, or as a civil engineer, how we can ensure the quality of the structure, right? So these four pillars are very much important in the assessment part. If quality of the material is fine, quality of the workmanship is okay, regular assessments are done, and at the moment, if performance is not at all bad, then we can say that the overall structure or quality of the structure is very nice. So these are some in situ testing methods. Most of us has performed some of the test so far. So first and foremost is visual observation. Generally, based on our experience, we can see that whether the crack is due to the material failure or structural failure. There are some NDT techniques like rebound hammer, probe penetration, and all that. There are some partially destructive testing, some chemical test, and for reinforcement corrosion test. I have few photographs of that. Let us see that. So these are some NDT techniques without harming the concrete. So everyone knows about rebound hammer and probe penetration. So I'm not explaining that. Then UPV is very much famous. GPR survey nowadays is very much famous. It also famous in subsurface utilities investigation, and also famous for the uh, for determination of places at which we can uh, make the uh, make the openings for the existing concrete structure. Then water permeability test, partially destructive, maybe pull out, pull off, maybe core test. So generally core test is being used to check the properties of the, or taking out the sample from the concrete for performing various tests on the concrete. Then endoscope is also one of the method by which we can find out the foreign matter into the concrete. Then carbonation test is very much common, and from our undergraduate we know that it is used for determination of carbonation depth just by using phyllophthalein. Similar to that, for prediction of corrosion probability, we use chloride content. Half cell potential and resistivities are very much common test for reinforcement corrosion. These are some wireless method by which we can get the result. So uh, this is what client wants, right? That they want result. But what is a typical answer from the engineer is site पे तो ऐसा ही चलता है, right? This is just an excuse like this small kit, so it should be avoided, right? So if we want, we can get the higher durability in concrete structure. As we have seen, it is not a rocket science. Everyone can achieve that, but that determination is required, right? And first and foremost is exposure class. So how it should be? First of all, current practice is not at all useful. We have to use other standard. We should take care that all degradation mechanism is taken care of, and it should be more real and accurate. And this is the, I guess, my last slide. So durability in general, in totality, is these 5 points. First and foremost, it should be introduced in our Indian standard. Local conditions and test method and selection should be made carefully. If it is being published in IAS, then that I don't find that there will be any issues that durability is that durability will be taken care of if we include this along with the test, right? So more robust QA/QC is required, and still SCM is taboo for concreting in many part of the country. So more focus is to be used or given on SCM, and always third party verification is required. So I guess this is all from my side. I hope I have not bored you, and you must have received some additional piece of knowledge from my this small lecture. I have taken help of from various research papers, document from ICJ durability handbook, and all other online resources. These are my contact details. Uh, First one is my personal email ID, and second one is my official one. So you can reach out to me if I'm helpful to you, if you feel so. Okay, thank you everyone. So if you have any question, you can ask.
Thank you, Rahul sir, for such an interesting session. The forum is open for questions now. If any participants or faculty member has any questions, please go ahead and ask.
Or if you have doubts, you can later on also ask on WhatsApp group or anywhere you.
Sir, no doubts.
Okay.
Actually, I had a doubt in GGBS product that the GGBS is can be used in the stage of plaster and any other stage, or it will be preferred for only foundation.
In plastering, it is not that much effective because uh, anyway, plaster is generally not considered as a structural part of
Okay.
the RCC. So it is not advisable to waste the material in plastering.
Okay.
Okay.
Any other questions or discussions? Anything is
Yeah,
welcome.
forum is open to all. So I guess I explained nicely so that no questions are there.
Yes, sir, we think so. So if anyone has any doubt and want to contact Rahul sir personally, then the details are given to you. This presentations as well as the recordings will be shared with you. So if anyone does not want to discuss anything or have any questions, then we end our session for today. Tomorrow, we shall start exactly at 2:30 p.m. So I request all of you to please join the session at 2:30 p.m. Thank you
Okay,
all.
ma'am.
Yes, thank you.
Yeah.
Okay,
Yes.
ma'am.
And
Thank you,
secondly,
ma'am. Thank you, sir.
feedback link will be provided to you in your WhatsApp group. So you please fill it.
That will help us to improve on our side.
Okay, sir.
Okay.
So, hello,
Yes,
ma'am.
yes, please go ahead. Yes, yes.
Yes, ma'am. So presentation will be shared through the mail only. The PPT.
Yes, we shall share the link. We will keep it in a particular drive and we shall share the link of the drive. You may go ahead and see from there.
After the whole 1 week, or you will share on a one.
Yeah, most probably
Most
after.
probably after the
Okay.
entire STTP is completed.
Fine, fine, fine.
Yes, I thank you all once again for joining. Have a very pleasant evening, everyone. Bye.
Thank you, ma'am. Thank you, sir.
Thank you,
Thank you.
sir.
Thank you, ma'am. Thank you, sir.
Welcome.
Welcome, everyone.
Thank you,
Bye,
sir.
everyone.